Hi, chemistry students. Welcome to lesson 2 for the week of April 13th. Today we're going to learn about the two parts of a solution and then learn just a little bit about electrolytes. So remember last lesson we said that all solutions are homogeneous mixtures of two or more compounds or elements. So we said homogeneous means they look the same throughout. Now solutions usually come in two parts. You have your solute, which occurs in a smaller amount and is what gets dissolved, and the solvent, which occurs in a larger amount and does the dissolving. So we're talking about salt water. Your solute would be salt, your solvent would be water. So a big chunk of what we're going to have you do for your end of the week quiz and your homework check today is being able to tell which is which. And I've got tricks for you. So solute versus solvent. Solute is a 6-letter word, S-O-L-U-T-E. It's the smaller word, and it's what occurs in a smaller amount. Solvent, S-O-L-V-E-N-T, is our 7-letter word. So the bigger word is whatever is going to be in the bigger amount. Okay, let me show you a couple examples. So here I've got just a little bit of some kind of probably copper crystal that I'm adding into water. So my smaller amount, a pinch of salt, is the solute, the smaller word. Bigger amount, 20 milliliters of water, is the bigger word solvent, and together we call it the solution. Okay? So other examples. Which one's the solvent? The bigger word would have to be the bigger amount, because you can see on the graduated cylinder you've got more. So that would make salt your solute, and then salt water solution. You can have a solution of two liquids. So if I add 1 drop of acid or 1 drop of food coloring, that's my smaller amount, so smaller word, solute, into the bigger amount, solvent, and together they are the solution. This is one students don't think of often. If we're talking about a carbonated beverage, we've got a solution of liquid and gas, because your CO2 is a gas. So which one is the solute? And the answer is there's a lot of solutes, okay? The solvent for soda would definitely be water. The main ingredient in pretty much anything we drink is water. The solutes, you can have multiple solutes, would be the sugar, the coloring, the gas bubbles, artificial flavoring, those types of things, okay? Now you'll have 2 sample problems in your notes today. So let's look at it. It says the air that we breathe is primarily made up of nitrogen, about 78%, and then oxygen, about 21%. The remaining 1% is a lot of trace elements, but primarily argon at 0.93 and carbon dioxide, 0.039%. Okay, so our questions, which the solvent and what are the solutes? Now you only get one solvent. That's the bigger word, 7 letters, so it's going to be our biggest amount. And solutes can be everything else, basically. Smaller word, smaller amount. So our main ingredient here you see is nitrogen, 78%. So that would be the solvent. And the solutes then would be everything else that's smaller. So oxygen, O2, argon, carbon dioxide, CO2. So you get one solvent and everything else we consider solutes. Our next example, which you're going to see a ton of on the homework, it should be pretty easy, okay? It says an alloy is 45% gold and 55% tin. Which metal would be considered the solvent? So solvent is our indicating word. That's the 7-letter one, so the bigger word is the bigger amount. And we see 55% is my bigger amount, so tin would be the solvent, okay? The solute would be gold. And overall, the alloy that they make would be the solution. Water's just, I don't know, nonsense right there. Okay, so that's probably 2/3 of what your homework check is today. Nice. All right, water is known as the universal solvent. And the reason we call water the universal solvent is because more substances can dissolve in water than any other known solvent. Now, not everything dissolves in water. If we're talking about like oils and fats and those types of things. But if you give it enough time, water is able to dissolve almost anything. How solutions form, and we'll speak a lot more to this next week. So I'm going to go quick through this. If you need to pause it, that's fine. But a solution will form only when the particles of the solute spread out evenly in the solvent, right? So the smaller salt spreads out evenly in the water, and it will only do that if there's a payoff, okay? It has to be worth its while, basically. So if the attraction between the solutes, the salts, and the solvent is greater than the solute alone, okay? So basically, salt is perfectly content to sit as a solid. If you put it in water, the only reason it dissolves is because it's more attracted to water than it is to itself. But if you put salt into vegetable oil, it does not dissolve because salt's not attracted to oil. Solutions can form in any combination of the three states of matter. So we're talking solid, liquid, gas. So you can have two solid solutions, okay? That would be like those alloys we were saying, gold plus tin or copper plus tin equals brass, okay? You can have a liquid and a gas. When we have carbonation, you can have different liquids. The air around us is just a solution of different gases, so. All right. We're not going to get into this too much from home. If we'd been in class, we'd get more into these notes. So again, I'm going to go pretty quick on this because I'm not going to ask you a lot about it, but I want you to see it. So pause if you need to. But our two types of covalent bonds. So we said first semester sharing is caring. Covalent bonds will share electrons between only nonmetals. Now, covalent bonds don't have atoms with full charges like ionic bonds do. So the example I put there is aluminum that has a +3 ionic charge. Okay, that's a big charge. But atoms in a covalent bond can form partial charges, which are very important. So down here at the right-hand corner of your screen, I have a water molecule. I have H2, you see your two white H's, and O, the red one. They are both nonmetals, so they will covalently share electrons. But oxygen is more electronegative, so he's the big brother, and he's going to hog the electrons. Okay, they don't share nicely. So that means the oxygen half of water is a little bit negative, and the hydrogen part of water is a little bit positive. And I'll explain why that's important. We would call that a polar bond because those electrons are being unequally shared. Okay? So we say it's a covalent bond because one element has a stronger pull on the electrons. Okay? That's important because now water, with its kind of negative side and kind of positive side, can act like a magnet because it has those partial charges. So it can attract or repel neighboring molecules, especially if it's trying to dissolve something, it has to attract the salt or attract the sugar in order to have it dissolve. Okay? Now, the opposite of a polar bond would be a nonpolar bond. And in a nonpolar bond, electrons are either shared equally or they're spread in equal directions. So a nonpolar bond would be like if you try to stick a magnet on a piece of drywall or a piece of paper. The magnet doesn't care. It's not interested. So nonpolar doesn't have any kind of electromagnetism or partial charges. Why do we talk about this? We'll talk more about this next week, but the idea is that like dissolves like. You're attracted to people that like the things that you like. Okay, same thing with solutes and solvents. So a polar molecule can dissolve other polar molecules. If you're kind of magnetic, then you attract other kind of magnetic things. Okay, so water is known as the universal solvent because it's very, very, very polar compared to other molecules, which means things are attracted to it and it's able to dissolve. Okay, like dissolves like. We call things that will dissolve in water hydrophilic, which is Greek for water, hydro, and philo, loving. So a water-loving molecule will dissolve in water. It's attracted to that polar charge. Okay, I know I'm going fast. It's because there's not a lot of questions about this on your homework. The opposite then. Nonpolar molecules are not magnetic at all. They don't have opposite charges, so they could care less about water's magnetism. Okay, they're not attracted, which is why you see these little bubbles or micelles form over here in the oil water. Oil is nonpolar. It has no interest in dissolving and mixing into water, so they don't form a solution. We call those things water fearing or phobia, fearing, right? So hydrophobic. And they will group together in order to avoid acting with H2O. Now, what's interesting about this is things that do dissolve in water, so polar things that will dissolve in polar water, will not dissolve in oil. Okay, so I have in my classroom, I wish I could show you, a little jar with 2 sugar cubes in vegetable oil, and it has been in there for 5 years since I started teaching at Oak Ridge, because sugar dissolves in water and it will not dissolve in oil. Okay, all right. The last big thing that's going to be on your homework today, other than solute and solvent, is electrolytes. Now, electrolytes, 90% of students go, oh, Gatorade, electrolytes. Yes, okay. So an electrolyte, just the definition you need to know, is a solution that conducts electricity when you dissociate or dissolve it in water, okay? Electrolytes are important to our body because our nerves and muscles communicate and move through electricity, okay? Those same electrolytes. Electrolytes dissociated in water form ions, okay? And I gave you this example here. This is sodium chloride, just regular salt. And when you put it into water and it dissolves, a special kind of dissolving called dissociation, you end up with a sodium +1 ion and a chlorine -1 ion. Now, electricity is when charges are able to move in a current. So here, because I have something ionic and I have those charges, if I move them now through water or your blood or your nerve, you're able to conduct electricity. That's why they're electrolytes or electrolytic. Don't stress these words too much. It's in your notes. I'm using the word dissociating. I don't want you to have a panic attack about that. But to dissociate means to kind of dissolve. I'm actually even going to skip to the next slide. Let me show you this. There we go. Dissociation is a more specific form of dissolving. Okay? Not everything that dissolves can dissociate. So sugar can dissolve, but sugar is not ionic. So you don't get charges. Salt can dissolve, but it also has charges, so it dissociates and is an electrolyte. And I will not ask you about that from home, okay? That would have been in our homework, but we've got enough to learn today. I think that's fair, okay? So what I do want you to know for your homework and your end of the week quiz is that electrolytes conduct electricity, and they form from ions or ionic compounds. Now remember, ionic compounds, we're talking about metal plus nonmetal. So you have to have something from both sides of the periodic table. Here's a nutrition label for Gatorade. What's the electrolyte in it? Water is covalent, H2O. Sugar, carbon, hydrogen, oxygen, all nonmetals, covalent. Citric acid is a special kind of ionic bond. Salt, ionic. Sodium citrate, that's metal, ionic. Monopotassium phosphate, ionic. So really, Gatorade is electrolytic because it's very salty. Now, people don't want to buy salt water and drink salt water. So look at this, they add a ton of sugar. So you can't taste the salt, but that's what it is for electrolyte, okay? Last thing, pure water, pure H2O, does not conduct electricity because it's covalent. So covalent molecules don't dissociate. Now, you're thinking water conducts electricity. Lake water or tap water, bath water, they do conduct electricity because there's other stuff in the water, all right? Here's our last little slide. I want you to find the 5. There are 5 of them. Find the 5 compounds below, which will dissociate into electrolyte solutions. What you're looking for, and up at the top I have a hint, is something that's ionic. You want to find the 5 ionic compounds, which means there has to be a metal and at least one other nonmetal. Pause it, find all 5. Good job pausing it and finding them on your own, hopefully. There's your 5, okay? So if they're only nonmetals, it's covalent, but the ones I put in red, sodium's a metal, gold metal, iron, magnesium, potassium. So those would be the ionic ones. On the homework, you would say those ones can form electrolytes because they're ionic. All right, the homework should go really fast. Good luck. Make sure you're taking it multiple times so that you are ready for that end of the week quiz. Thanks, y'all.